Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video we're going to look at the power system that I'm using for Fred. Now, I had a request in one of the videos to better explain the layout and connections of Fred and his power system. Now, this was in a video I think to do with the head, so what I thought I'd do is first go over the reasons why I'm doing or running the system the way I am. So I've got these 20 volt lithium ion batteries that I can use to power the robot with. And if I hook those directly to our servos or to the Raspberry Pis that are in Fred, they will generate a large amount of smoke, which we don't want to encourage our robots to smoke. So to get around that little issue, we're going to use switch mode power supplies to drop the voltage down to what's required for each of the devices. Now, in the head of Fred, I used two of these buck boost AT30 modules. Now, these are only rated to 3 amps, which is enough to run a Raspberry Pi and the servos that are in the head. So there are two of these, one for the Raspberry Pi, one for the servos. And I've got those in this diagram. I'll bring that up clearer shortly. So the one for the Raspberry Pi 4 is actually set at 5.1 volt DC and feeds directly into the Raspberry Pi. And it's capable of supplying up to 3 amps without a problem. Now, it's a buck boost unit, which means if the voltage that is being supplied falls below the target 5.1, I think we can go as low as 2.5 or 3 volts. It will actually boost the voltage up to the 5.1. So it'll keep us with the right voltage to run the Raspberry Pis. I actually used the same one for the head servos, although it wasn't strictly necessary. I could have used this smaller one. This one's an XL4055 and it's rated at 5 amps. It would probably actually be a better one to use for the servos and the head. Give us a little bit more headroom, so to speak, on the voltage. Now, on the back of Fred, I've added 2 switch mode power supplies. Another one of these buck boost units for at 3 amps to power the Raspberry Pi and the LCD touchscreen that's on his back. And I'm also using it to power the little network switch. It's a little 5 volt network switch. Now, for the servos that are connected to the PCA 9685 on the back, and remember these things can power up or drive up to 16 servos, we need something with a little bit more beef. So I had a look to see what power supplies I had available. There was this little unit, I can't find the part number for it, but it's only rated to 12 amps. So it would drop the 20 volt down to our 6 volt that we need, but only at 12 amps, and that's probably not quite enough. This one, on the other hand, is a buck unit. It will supply up to 20 amps while dropping the voltage down to 6 volts DC. So this is what I've got mounted in his back, and I've got 2 more of these, one for each arm. So I've already added the arms in the diagram. And this allows us to significantly change the power. Now, power is volts times amps, and motors, servos, etc. use power. Now, when you're looking at, say, the back, we can supply up to 20 amps there at 6 volts. So 6 times 20 is 120 watts. And at 20 volts, that 120 watts drops back down to around about the 6 amp mark. So instead of supplying 20 amps, we're only drawing 6 amps. Now, there are losses in the power supply, so it's a little bit more than 6 amps, but it's still significantly lower than the 20 amps. So when you start adding them all up, we're actually going to be drawing a lot less amps, which means I can get away with a smaller power supply, or at least in the short term. So the power supply I'm using to power Fred when he's not on batteries is actually a 12 amp adjustable voltage unit. And if I start to run out of rooms on the amps, I can always up the voltage, because these units will take up to 30 volts DC in. And if we increase the voltage, we decrease the amps. Now, looking at this small unit, this is all soldered together. So the end with the adjustment for the voltage is our output, the positive terminal being at the end here and the negative being on the outer edge. And of course our input's on this end. There is a fuse on this unit, so there's also an LED on it down. It's a surface mount LED. It lights up when this thing's working. If you blow that fuse, it will cause that LED to drop out. When you're setting these up, connect your voltage to the input, but don't connect the output yet. Turn on the power, and with a multimeter connected, adjust your little potentiometer here to get the voltage to the right level. These things come pre-configured for 12 volt DC. So if you connect that up to your Raspberry Pi and power it up, your Raspberry Pi will start smoking. Again, we don't want it smoking. It's a bad habit. It results in premature death to the Raspberry Pi. So make sure you adjust the voltages on these power supplies before you connect them to your end devices. The same goes with the big ones. This one was also configured originally for 12 volt DC output. So I've actually turned it down to the 6 volt that I require on its output terminals here before I connected the servos. And I will put a link in the video where I actually configured this one. And I think I had in one of the videos where I configured this one before I turned it on as well. So I'll put links to both of those in the description. So that'll do for this video. If you like these videos, don't forget to click on the like, subscribe, and ring that notification bell to be notified when new videos come out. I have got a Discord server. The Discord server is a good spot to ask questions and get answers. And I have a Patreon account, so you can always support me if you choose in Patreon. A big thanks goes out to Go Lucky, my #1 Patreon. And we'll see you in the next video.